Last week, I finally decided to investigate another open source tool to monitor and manage my UPS devices. I was looking for a tool that could help me unlock the data inside of my UPS, allow me to do some shutdown coordination, and let me see my UPS data without having to look at the LCD screen. That is, if you're lucky enough to have one. So when it comes to managing power devices like PDUs or UPSs, you should look no further than NUT Server. NUT Server, or Network UPS Tools, is a service that you run on your machine to monitor the status of a connected UPS. It works with over 140 manufacturers and maintains a common interface to communicate with the UPS. It also has cross-platform support, so you can run this on Linux, BSD, or even a client on top of Windows. And it also has multi-architecture support, meaning you could run it on ARM, x86, or x64. So we can run it on a server, a desktop, or a Raspberry Pi. Personally, I think one of the coolest features of NUT Server is being able to run the client on a remote machine and have that system shut down when the UPS server tells it to. And that's without connecting it to that remote machine. This means you only need one system connected to the UPS that's running NUT Server, and all the other clients can just listen or subscribe to changes on that UPS. So with all of these features and device support, it comes with some complexity. And to be honest, it's taken a while for me to get my configuration just the way I want it. And while NUT Server has diagrams covering a simple configuration, an advanced configuration, a big box configuration, and even a bizarre configuration, and hopefully mine doesn't fall into the bizarre configuration, because I think my setup falls into the same category as most people's home labs do. So today, we're gonna configure all of this and more. We'll configure your UPS and the driver. We'll configure the NUT Server and the NUT client. We'll also configure a web interface to see all the graphs and data for our UPS. And if there's enough time, we'll also configure a secondary UI using Docker. You knew I couldn't do a tutorial without Docker, but it's not required. We'll also configure a Windows client for NUT, and then finally, we'll configure remote monitoring and shutdown for your NUT Server and NUT clients. And don't worry, I'll have all of my configuration in my documentation site, and you can find that in the description below. And if any of that sounds good to you, don't forget to like this video and subscribe if you haven't already. So let's talk about some hardware that you'll need. First up is the most obvious, it's a UPS. You'll need one of the supported UPS devices that NUT supports. So I've connected 3 already, 1 Tripp Lite and 2 APCs, and they've been working really well with some tweaks. The first UPS is a Tripp Lite 1500 LCD Smart UPS. It's the rack-mounted one that powers all of my servers in my rack. This includes both 1U servers, my disk shelf and all of its disks, and another server, at least while it's on. The next UPS is an APC 1500 UPS Pro. This one's not rack-mounted per se, but I did mount it inside of my rack on a shelf. I didn't want to rack mount this one because of the limited space, and I want to do a few things different in the future. This one only powers my main networking equipment, my UDM Pro and my Unify Switch Pro 24-port PoE switch. I have this on a separate UPS because I want my network switches, access points, and all my connected PoE devices to stay on longer than just a couple of minutes that I get on my main UPS. The last one is an APC 850VA UPS battery backup and surge protector. This one's a little more consumer friendly with its ports and its price, but it lacks the LCD screen, which we'll actually fix with NUT Server. This one powers most everything on the wall, but mainly my fiber modem. This UPS will power everything on this wall for about 3 hours, which could also dub as a phone charger or tablet charger if the power was out that long. And that's why I've separated this one. So those are the 3 UPSs we'll be configuring today. If you're interested, I'll have some links to these UPSs that work with NUT in the description below. And don't worry, if you don't have one of these or these specific models, the configuration is almost exactly the same for most UPSs. You'll want to check the hardware compatibility list to see if yours is supported. And even if you don't see yours listed there, it'll most likely work with a generic USB driver. So next up, you'll need a system for this to run on. Like I mentioned before, you can run this on various operating systems and processor architectures. So really, the choice is up to you. But I'm going to run mine on my Raspberry Pi. My Raspberry Pi 4B has 4 USB ports, which is perfect to connect my 3 UPS devices. Now, this might seem odd at first, and it might even fall into the bizarre category that we saw in the diagrams earlier, but I don't want NUT to be running on one of the machines that's going to be shut down. So I want this Raspberry Pi that's running NUT server on until the power completely drains from the system. Now, I can tweak that later and shut it off when the power is at about 1%, but really, I want this on no matter what. So we'll get into that here in a little bit. So I'm gonna connect all 3 UPSs to this Raspberry Pi in the USB ports. And it doesn't matter which ones you choose, as long as they're plugged in and attached snugly. And a side note, this Raspberry Pi is actually PoE powered, so it'll run off my switch's UPS if the power dies. And this is another reason why I've kind of broken up all of my UPSs. But after they're connected, just make sure that your UPSs are turned on and they're not running on battery power. Now it's time to configure the driver for your UPS, and then we'll configure NUT. So you'll need to open a terminal on that machine where the UPSs are connected, or SSH into it. Once you're in, you'll want to run ls-usb. So this will show you all of the USB devices and what bus they're connected on. So you can see here I have an APC device connected, another APC device connected, and my Tripp Lite UPS connected. And now we can install the NUT server. The first thing we'll want to do is update our repositories. Then we'll want to install NUT, NUT client, and NUT server using sudo apt install NUT client, NUT server. Next, we'll use a utility called NUT scanner to actually probe all of these devices and get some information from them so we can configure them a little bit easier. And that's as simple as running sudo nut scanner -u. Then, after you run that utility, it will go ahead and scan and probe those devices. So you can see here my first one, nut-dev1. You can see the driver is going to use this generic USB HID UPS driver. It's detecting the USB port as auto. It gives me a vendor ID and a product ID, which is important for Tripp Lite devices. And then it gives me the product name, the vendor name, and a bus ID where this is attached. And you can see the same thing from my APC devices. And this helps us with our configuration. So copy and paste this or make note of it so we can use some of these values in our configuration. So our configuration is stored in etc nut.upsd.conf. So let's edit this file. And if we look at this file, we have a lot of settings that are commented out. And so we could edit this file, but what I typically do is just copy this example over to an example file and then create a new one myself. So I close out of here, and then I'll back up this file to an example file using this command. Then I'll go back and edit this file again, and I'll clear out all of its contents. Now, you might want this for some of the examples there, but it's pretty noisy, and I know the settings we need. So a couple we're gonna add is poll interval equals 1. This is how often it's gonna poll that device, and max retry of 3. This is how many times it's going to retry to connect to that device before it deems it as failed. And these should be pretty low and should rarely ever fail because it's communicating over USB. So the only time this should fail is if the device isn't connected. Next, we're gonna create our devices. So in this directive here, we're gonna create our first UPS device. Now, you might only have one, so only do this once. I'm gonna do all 3 so you can see all the examples of how to configure UPSs for other manufacturers. But this first one is my Tripp Lite device. Now, I've named this Tripp Lite, and it can be anything you want it to be. I've just named it according to something I'll remember. Now, when you name this, you'll need to make sure that you don't have any spaces in here, and you don't have any special characters. So I'm just gonna name mine Tripp Lite here, like this. Next is the driver. Now, the driver most likely is USB HID UPS. Now, how did I know this? Well, we used the scanner that told us that's the driver to use, but you can also look on their hardware compatibility list that I mentioned earlier, and it will tell you which driver to use. But most UPSs I've seen use this generic driver. And if you use the scanner and it told you to use something else, just plug it in there. Next, the port is for auto. That's because we got it from the scanner. And next is just a friendly description for you that you'll see in the website and in your configuration. And it's just a mental note of what this device is. The vendor ID is important for Tripp Lite, more than the others. So for Tripp Lite, you actually need this vendor ID, 09AE, or depending on what the nut scanner told you was going to be. And the product ID is also important too. The product ID is 2012. This must be the year they created this. I don't know. And those are really the only values you need for Tripp Lite. And for APC, it's almost the same. So here are my two APC UPSs that I'm connecting. So this is just the name that we're going to use elsewhere to refer to this. The driver, again, is the same generic driver. Port is auto, a description. Vendor ID is different from Tripp Lite, but we'll still need it for APC. Product ID too, and then a serial number. So this one is important for APC devices. So we should have seen the serial number that came out from the scanner, and you'll just plug it in here. And the same goes for this APC here. So as I mentioned earlier, this APC network is the one that's powering my network devices. And this one called APC modem is powering my modem and a few other devices. And it looks exactly the same except for the description. And then the serial number will obviously be different too. So once we have that, we'll save this and we'll close out. Next, we're going to configure upsmon. It's part of NUT. And that configuration is stored here. So it's in etc nut upsmon.conf. So let's edit that. So in here, again, you'll see a bunch of values and default values and documentation within this configuration file. But I'm going to clear all of this out to reduce the noise. So again, I'm just going to copy this config to an example, and then we'll edit this one again, and we'll clear out all of the values. Now, there's probably a better way to do this, but this is a lot to scroll through, as you can see, when you want to configure this later. I'm still deleting. Okay, there we go. And also, NUT server is very well documented. You can find all of this documentation on their website. It's impressive how much things are documented. So I might not dive deep into each variable, but know that NUT server has done a great job documenting this. So in here on upsmon, we're going to set up monitors. And so the way we set up monitors is like this. So I'm going to say monitor Tripp Lite, that's the name of that device we configured a little bit ago, at localhost, so this machine. And then 1 is how many UPSs are connected to this device. Next is the account, which I'm using admin, and then a password, and then whether or not it's a master or a slave. So let's talk about these. So again, we're setting up monitor. This is my username for that device we just configured. At localhost, it's this machine, so it's going to be monitoring that service on this machine. How many UPSs are connected, and then some credentials, and then whether or not it's a master or a slave. So the way I set mine up is I treat mine as a master if it's physically connected to the UPS. So this one is physically connected to the UPS, so I'm going to say he's master. And for me, it's easier, rather than using master and slave, to use client or server terminology. Now, I know it's not a one-to-one with the way that they designed it, but it's easier for me in my head to think this is going to be my server and other connected devices will be the clients. Anyways, so I set up 3 monitors on this, one for each of my UPSs. They're all set to 1 because they have 1 UPS connected. They're all going to use the same accounts, so admin. They're all going to use the same password, which is secret, and you can set this to whatever you like. I think there's a limit of 8 characters on this. Don't quote me on that, but I would use something around 8 characters in random. I'll sprinkle one in later. And then these are all going to be masters. And then there's one more setting that I've set up, and it's to run this as root. Now you can set up additional accounts and restrict this service to be able to run as a different user. So I'm taking a little bit easier approach and saying run this as the root user, because the service that this is running as will need to do some additional things that require root permissions. So anyways, we'll want to save this upsmon.conf, and then we'll close out. Next, we'll want to edit etc nut.upsd.conf. And when we edit this, again, we're going to see lots of documentation built into this configuration file and no config. So what do I usually do? We copy it to an example file. We edit this file again, clear it out, and we start all over. So in this file is where this service is actually going to listen on. And most of the time they'll tell you to listen on localhost, so 127.00.1, and it's on port 3493. And that's great if you're running in standalone mode, where you only want to communicate with yourself. But I actually need to communicate with this from other devices. So I'm actually going to listen for all IP addresses. And I do that by setting it to 0.0.0.0. And so if you're not going to run this in a client-server configuration between two different machines, you can set this back to localhost. But if you are going to connect to this from another machine, you'll need to allow this address for 0.0.0.0. So let's save that. Next, we're going to edit the NUT configuration. So that's etc nut.nut. Well, hold on. That's etc nut/nut.conf. Too many nuts. So we'll edit this. And again, a bunch of documentation and a little configuration. So what do? Copy it, then edit it, then clear it out. So the only thing in here is mode equals none. So as it stands, it won't work. We actually need to set a mode for this. So I think there are a few modes here. I don't think none counts, but I guess so. So mode of none, I don't think it'll do anything. Then there's mode of standalone, which is the mode you would put it in if you're only going to run the NUT server and NUT client on one machine. Then there's mode of net server or net client. So for me, I'm actually going to set it to net server. So this means it will serve out that API information on this machine to clients who connect, who set theirs to net server. We'll do that in a little bit. So let's save that. Next, we'll need to configure users. So you saw earlier on our monitors, we had a user of admin and a password of secret. This is where we'll actually configure our users. So if we edit these users, again, tons of config and documentation built into the config, and no active configuration. So I'm going to copy it out, edit, clear it. And again, I only do this so I have pristine versions of the original file called example. And then I don't have a bunch of variables spread across 100 lines of config, because I've accidentally defined the same variable twice, and I think the last one that gets defined is the one that wins. And so you'll rip your hair out trying to figure out why something won't work, because you set it on line 2 and on line 102. Anyways, enough of that. Do this however you like, but this is how I do it. So in here, we're going to create a mon user. So this is the user we're using to connect to this service to get information from the UPS. And as you can see here, I just named it mon user. This could be anything. And then my password is secret. That's what we set earlier, or it could be random characters. But we're going to set it to secret. And my account name is admin, and it's actually the master. Now, you can get pretty detailed and pretty fancy with users and settings. I'm keeping this pretty basic. But if you have more needs, I highly recommend looking at the NUT documentation for upsd.users. It explains some of the advanced permissions you can give to this user and how you can restrict permissions to either a master or a slave, and whether or not they can perform certain commands. But for me, I'm keeping it simple and setting the password here and setting this admin as a master. So we'll save here and close out of here. And now we should be able to restart all of our services. Now you can do this one of two ways. You can run a whole bunch of commands to restart each individual service and the driver, or you can just reboot the device. Rebooting is definitely easier, or you can run all of these commands right here. So once all the services are stopped and restarted, we can start to see some communication happening. So these messages that we're seeing are the ones we configured in upsmon. So upsmon right here is actually monitoring the UPS service that we restarted. And you can see here, I updated my password. It's no longer secret, so take note of that. Use something else. Don't use these random characters that I used. Use something else. But because it's monitoring Tripp Lite APC modem and APC network on this machine, when that service restarts, it says that it lost communication with the device and that the devices are now unavailable, and it should be reconnected to the server. So let's test it. So we can test or query this UPS through the NUT server by running upsc Tripp Lite, or the name we set up, at localhost. And if we run that query, we can see a lot of data coming back from that UPS. So you can see here, my UPS has a battery charge of 100, a runtime of 794 seconds, so a little over 10 minutes, the battery voltage, the name that we set up earlier, the name that came back earlier, the model, the driver we're using, the poll frequency. So we can get a lot of this information. And you can even query individual variables if you want to. So if we wanted to query and see what's the battery charge for this device, we would run that same command and put the variable afterwards, and it would tell us, hey, it's 100. This is pretty cool. So we can do the same thing for the other ones too. We could run the same command for APC wall or APC network. And that's cool, and it's nice to see this information, but we actually would like a web page for this and graph this too. So if we want to install a web server on this device to serve out the information through a web page, we would do it like this: sudo apt install apache 2 and nut-cgi. Then we'll say yes to this prompt. Then once it's installed, we'll need to modify some configuration. So we can edit this config file, etc nut/host.conf. So same pattern here, a config file with lots of documentation built in. We're gonna copy it, edit it, and clear it out. And in here, we're gonna paste a configuration that looks just like our upsmon.conf. We're gonna tell it to monitor that device at localhost and give it a friendly name. So my Tripp Lite, I gave it a friendly name of Tripp Lite 1500 VA, Smart UPS, and Rack, so I know. And for APC, I said the APC 850 VA on the wall. And then for APC-network, I said the APC Backup UPS Access 1500 on the rack. So once we save that and close out, then we'll run this command, sudo a2 mod cgi, and that's just enabling a module, I think for Apache. Then we'll need to restart our Apache server using this command. So after we restart it, we'll need to modify one thing, etc nut upsset.conf. And in here, same idea. Back this up to an example. I'll clear this one out, and then we'll need to uncomment this one line, which I have secured my CGI directory. And then we'll save this, close out. Then we should be able to go to the IP address of that machine, or DNS entry if you use it, /cgi-bin/nut/upsstats.cgi, and see our statistics. So here they are. So here's my Tripp Lite one. We can see it's online, the battery's 100%, we can see the input, output, and the current load, and the current battery runtime. So this one only gets me about 13 to 10 minutes, depending on the load. And if we drill into this machine, we can see some charts here. So we can see it's 100%, the voltage, the input, output, and just what we saw, the load. So it's just under 50, so about 40%. Not 40%, it's right there. And if we go back, we can do the same thing for our APC. So my APC, 4% load. The output is not supported, but the input is, and you can see the charge and voltage here too. So this is the one that powers a couple of devices, but mainly my fiber modem. And then next is my APC one that's in the rack. You can see that this has an hour and 44 minutes of runtime. And you can see the current load is only 7%. Now that's pretty awesome because this is my UniFi Switch Pro and my UniFi UDM Pro with all connected devices, including multiple access points, multiple mini switches, multiple Raspberry Pis, and lots of cameras. So that whole system can run for an hour and 44 minutes until it totally dies. And this is why I separated them out, because I have a tiered approach to where my servers will shut down first, then my UniFi will shut down next, and last but not least is just my fiber modem. Now I can't do much without my UDM Pro, but if I get to that point where I've been off power for an hour and 44 minutes, I know that it's gonna be off for a lot longer. So I want this battery just to charge my devices, and I'll hook up an old router if I really need internet access, but most likely I'll just set up my phone, charge it, instead of tethering. Anyway, and then we can actually see the data tree. So this is all the data we saw when we queried the client. It's the same information, but just presented in a web page. So pretty cool, we got this set up. So the next UI is just an alternative UI, and it gives you a lot of the same information, but in a different way. So the next one is called WebNut. This is actually a Docker container that you can use to host on a totally different machine to query your nut server to get this information back. So I'll talk through this really quick because it's not necessary, but it is cool. So this Docker Compose file, pretty typical. We're setting an API version, we're configuring one service, we're calling it nut, we're using this image technologist/webnut, the container name I'm naming WebNut, and then I'm setting up some environment variables. So this is the host that the UPS is physically connected to and the nut server is running on. Now it technically doesn't need to be physically connected to it, but I won't get into that. But it's the one that nut server is running on that's serving out the information. So for me, that's 192.168.0.120. Then the UPS port, this is going to be 3493 in most cases, unless you changed it, but I highly doubt you did. Next is a username that we use, so ours was admin, and then a password. Now I have this random password here, yours could be secret, hopefully it's not password. It's the password you use to communicate with your nut server. And then we say restart unless stop, and this helps if the container starts crashing. It'll just restart itself, unless you stop it yourself. Security options, this is one I typically use. No new privileges equals true. And so this means the privileges within the container can't be elevated. And then we're gonna expose some ports. And I got one wrong there. It should be 6543. So 6543 on the outside, 6543 on the inside. Left is outside, right is inside. Left is 1, you can change yourself. So if you wanted this on 80, 8081, we change it here. But on the right side, you can't change that because that's how they built the container, but shouldn't matter. So anyways, we should be able to use this Docker Compose file, create a Docker Compose file, edit that, paste in all of our contents, and then save it. Then run docker-compose up-d-force-recreate. I know I don't need to say force-recreate, but I use that command every time because it works every time, whether I'm starting it, creating a new one, or replacing it. So we can run that command, it should pull down that container, and it should start it up. And if we go to that IP address and that port, we should see our UPS devices. So we'll see the same UPS devices that we listed. So I have Tripp Lite, APC network, and APC modem. So if we go into my Tripp Lite, we're gonna see a lot of the same information here. You probably wanna show more records than 25 because it gets clipped off, but so here again, we can see all of the same information here. But we don't get charting, which we got in the other one, but still, this is really nice to be able to see. And I figured I may as well mention it. Okay, so I also mentioned a Windows client. Now, we can run a Windows client to monitor that same status information from that UPS. And we can do that using this client called WinNUT-client. So on their GitHub page, all we need to do is get the latest available release. I'm not gonna go with a pre-release, it's probably fine, but I'm gonna go with one of the stable ones. And I'm gonna download this MSI here. Once we download the MSI, we'll want to install it. And once it's installed, we can launch it. So once you launch it, you'll wanna go into settings and we'll wanna configure some settings for it. So here you're gonna specify your nut host. So this is the host that's actually running nut server. And for me, it's 192.168.60.28. Now you can use the DNS name here. I highly advise it, but this is the IP address of that machine. The nut port is the same port again. So it's 3493, same port we saw when configuring WebNut. And then the name of your UPS. So this could be the APC that I had. So APC wall or APC network, or it could be Tripp Lite too. Then we're gonna set up the polling interval, 5 is usually fine. Then we're gonna set up our login and our passwords or our credentials. And this was the same login and password that we used everywhere else. So mine is admin and then your password, which is hopefully not secret, hopefully not password, but it's a real password. And then we should be able to just hit apply and okay. And you can see right now that it's actually monitoring my UPS. So you can see the same information we got before. So the input voltage, the frequency, output, battery charge, UPS load, and the battery voltage. So this is pretty cool. So this is connected to my Tripp Lite. So I could actually shut this down if that machine were to go down. Now, this doesn't make a ton of sense in this scenario. I'm just showing you this how it works. But it could say once that battery, so that battery that's connected to my server rack, gets to 20%, shut down this machine. Or it could also shut it down if the runtime is lower than 120 seconds or 2 minutes. Hit apply and OK. So now this machine will actually shut down if that goes on UPS power. Now I said this doesn't make a ton of sense because if that's on UPS power, that means there's no power in here. And I do have a UPS connected to here, so I guess it kind of makes sense. But you could see how you could use this, say, on virtual machines or something like that. If a Windows virtual guest is running on, say, your hypervisor and you want to shut that down when the host goes to UPS power, you could do that. And there's a million use cases. I'm just showing you the Windows client, which I think is pretty good. Now we have one more configuration, and that's automatically shutting down another machine based on NUT server's status. But before we do that, I should probably mention something about Tripp Lite. Tripp Lite took the most configuration to get working, and I figured I should dive in just a little bit deeper for just a minute to explain a couple of things. Because this UPS is pretty common for home labbers in their racks, I figured I should mention this. But if you're having troubles configuring your Tripp Lite UPS, it might be because the device is disconnecting over and over. So how do you know that? If you run dmesg, I don't know how you pronounce that, dmesg. If you run that, you'll see your device in here. And before I applied this fix, you would see this device connecting over and over and over about every 10 seconds. And it's pretty annoying because when it does that, it actually can change the bus and the device ID. And so as it's changing, the NUT server has no way to get a reference to it to be able to query it. So you end up in this weird, crazy loop. So the fix for it is actually to create this udev rule. So we want to edit etc udev rules.d called 999-nut-ups.rules. And this could be named anything you want. You should probably put it higher than what's in there, so 99 is usually a good fit. And a huge thank you to PC Geek from the community for sending this to me, because this actually solved all of my problems. So thanks, dude, appreciate it. And if you don't know PC Geek, he's part of our Discord community. And if you don't know about our Discord community, you should totally join. But thanks, dude, appreciate it. So we'll want to create a new rule here. Helps if I have that path right. So it's /99 nut UPS rules. I copy and pasted my own comments. Copy pasta. So anyways, we'll edit this rule. And in here, you'll want to paste all of this. Truth be told, I don't understand a lot of this, but I actually found an old Stack Overflow post that PC Geek pointed me to that then referenced some old archaic email from someone who worked at Tripp Lite who said to apply this. So the internet told me so it must be true. So anyways, once you apply this, I actually had to reboot. And after I rebooted with this applied, then I no longer saw the device connecting in dmesg. And then the NUT server was actually able to connect to that device. If you're not using Tripp Lite, don't worry, don't apply this, please don't. Won't help anything, I doubt it'll hurt anything, but won't help. But if you are using a Tripp Lite, because like I said, it's popular among home labbers, you'll want to apply this and then reboot your system. So anyways, back to what I was saying. Now we actually want to install NUT client on another system and have that system communicate with NUT server and get status information from it. And the reason why I want to do that is because I want to automatically shut down remote systems if the NUT server says it's low on battery or it's been running on battery for a certain period of time. And so this is how I'm going to orchestrate shutdowns of all of my hypervisors. If the NUT server that's running on my Raspberry Pi says the battery's at a critical level. It's pretty cool. It's pretty easy too. Well, after you know how, it's pretty easy. So I'm going to remote into one of my Proxmox servers. This one's called Helios. And on here, we're going to run apt update. And we don't need sudo because we don't have sudo on Debian on Proxmox. Then we're going to run apt install nut-client. So we're only going to install the client on this machine. And if you're using something that uses sudo, like any version of Ubuntu, apply sudo here. But we're going to install the NUT client here and configure it to communicate with our NUT server. And then once it's installed, we'll want to modify our etc nut upsmon.conf. Now this should sound familiar. It's the same configuration that we configured on the server so that the client could communicate with the server on itself. It's kind of confusing, but on nut server, the first one, we installed both the client and the server so it can communicate with itself. So now we're going to configure this upsmon.conf to communicate with our server. And here's the configuration. Now again, you'll have that example configuration. You'll want to back that up and copy it to an example file like we did at least 15 times. And then I clear it out and start all over so I have a clean slate. Now, I'm not going to go through everything that's in here, but I'll cover the highlights. And again, I just want to reiterate that everything is super well documented on Nut server on their website, and I'll have a link in the description below. So we're just going to cover the highlights. But again, we're going to say run this as root. This monitor might look familiar because we had it on our Nut server, but here we're telling it to monitor one UPS, and that one UPS, the user or UPS name was APC modem. So I'm telling this to monitor APC modem, and this is the IP address. And this is how many UPSs it has connected to it, only one. And then the user, which we set up, and then the password or the secret. Now this should be secret or password, but not those values, your own secret or password. And I assure you, I'm gonna change this after this. Thanks, Defender, no viruses. Okay, anyways. And then here I'm configuring it as a slave. So really, this is basically saying that this machine depends on the other one. I'm gonna call it client server, except for it's a little more nuanced than that. But this client depends on the other server. So if the other one is in a bad state, this one will consider itself in a bad state too. But we're gonna configure a few things. We're gonna say minimum supplies are 1, and this is the minimum amount of UPSs that can be alive. So some machines have multiple UPSs and they can fail over, super fancy stuff. I don't, I have 1. So I'm saying I only need a minimum of 1. Here's the shutdown command. So this is the shutdown command that's defined if it needs to shut down. So how does this machine shut down? Well, he runs sbin shutdown-h. If you're running a different flavor of Linux or some other machine or Unix-like machine, check to see what your shutdown command is and set this here. Notify command is what it runs to execute notification messages. So it runs this upssched command, and we'll see that here in a little bit. But when certain things happen, this is the binary it's going to use to send out these commands. Poll frequency, poll alert, pretty self-explanatory. Hot sync and dead timer, pretty complex, but 15 is a good value according to their documentation. This power down flag is actually how it kills power to the UPS. This one is kind of dangerous because I accidentally triggered it a couple times and sent it to my UPS server and it shut down all 3. But this is just so it knows how to do it. Not that we're going to use it, but just so it knows it's defining it. And then a whole bunch of notifications. So notifications are defined and doing a little bit of formatting of the messages. And then what happens when we get these notifications? So when we get these notifications, so this is the way I understand it, it's going to write to syslog. If you do a +wall, I think it's going to broadcast this message to all the listeners. And then it's also going to exec something. So it's going to exec this notify flag of online. When the UPS comes online, it's gonna write to syslog, broadcast a message, and then exec whatever we defined for online. And you'll see that here in a little bit. And the same thing for all these. So we have these different events: on bat, low bat, FSD, common, com, okay, com bad, shutdown, replace battery, no communication, no parent. So a lot of things defined there. And then there's a couple other that they have defined in their example that I carried over that they say to use. So once we have that, we'll save that. Then we're going to modify the nut/nut client configuration. So this is the nut client configuration on this machine. And in here, I didn't follow my own pattern, but what we should be doing is copying this off and then creating an example and then using this. So here, the only important piece is mode, and the mode is net client. So on our server, we had net server. On our clients now, we'll have net client. This is basically saying, hey, I'm a client to that server. That's where I'll go for communication messages and statuses and querying to see if my UPS is okay. So we'll set this in net client. Next, we're going to modify one last file, and it's etc nut upssched.conf. And we don't need sudo on Debian. Oh. Anyways, this is the commands that we saw from the exec earlier. So let's talk about this. So first, we're saying, hey, we're going to run a command script. And where's our command script located? We put it in etc nut upssched-cmd. Now we don't have this file yet. We'll create it here in a second. But it's actually going to run that script when one of these events happens. Python and Lockfin, just going to pronounce them. But these are also necessary to create the pipes and lock files in this directory. So Python and Lockfin are just our directories where pipes and locks will be written to. And then we're defining a few things here. On-bat, and we're setting a timer. So on the on-bat event, we're going to start a timer and call on-bat and set the timer for 30 seconds. When it's online, we're going to cancel that timer and say on-bat online. And then on battery, if we get to this point, we're going to start a timer and then we're going to call early shutdown. And I set that for 30 seconds. Then on low bat, we're going to execute on bat. And then when we get the command communication bad, we're going to start a timer for 30 seconds. And then if communication is okay, we're going to cancel that timer and execute communication okay. No comm, we're going to execute comm bad. Shutdown, we're going to execute power down. So this is just mapping from the event with parameters to this file, the CMD file. It's kind of confusing. It confused me a ton over the weekend. So let's actually check out this file now. So we'll save that. Then if we edit this file, which you might not have, so you want to create it, but we'll run a nano etc nut upssched-cmd. And if we open or create this file, you'll want to paste these contents into it. So this is the shell script it's actually going to run. So this looks like a case statement. So on battery, that command we got, it's going to log out the output of upssched-cmd. The UPS is on battery. So this is what happens immediately when it goes to battery. The next piece I defined is early shutdown. So when that timer hits 30 seconds, it's going to call early shutdown. And what this is going to do is going to log out and say the battery's been on for too long, force shutdown. And then it's going to call upsmon with -c and FSD, force shutdown, I think. And it's going to do the same thing for critical. So I have two events that I've wired up. If it's on for more than 30 seconds, it's going to shut down. And if the battery is actually critical, it's going to shut down. Now, how would I have one without the other? Well, if it was running on battery, say for 10 minutes, and everything was shut down and it had 2% left, when it came back up and the battery was still critical, it would shut this back down. Now, that's a lot of automation that I still haven't done yet, but that's the idea. And so once we have this and we save this, we should be able to trigger this. Now, there are some fancy commands you can run on the host machine to trigger this. But I think the best way to actually trigger this is to actually pull the power. So I'm going to show you what this looks like when it actually happens. And real quick, one thing I kind of skipped over is that we should actually test this really quick, and it's really easy to do. So on the right side is my Proxmox machine that we just configured. We configured a lot on it, but we want to make sure that we can communicate with the actual server. So on the left side, I'm actually SSH'd into that Raspberry Pi, which has the server running. So the first thing you'll want to do is actually restart the NUT client with our configuration. After we restart it, we should be good and we should be able to communicate with our server. And the way that we query it is the same way we did it earlier on our local machine. So on my remote machine, I'm going to say UPSC, Tripp Lite, or whichever modem you want to communicate with, and then the IP address. If we do it, I should be able to communicate. So that's pretty cool. That means it works. And on the remote machine, if you actually want to test disconnects and reconnects, and on my NUT server, I can just restart the service so that all clients connected to it will get disconnected and then hopefully reconnect. So I can do that by using sudo systemctl restart NUT, not client, but server. If I do that, supply password, I should see a disconnect, and we saw it on the right disconnect before the left. See the left disconnect, and then communications reestablished on the right. So this means it's working just as it should. There's only one thing left to do, and that's actually go down and unplug the power, wait for 30-ish seconds, and we should see the one on the right reboot. So top left is the server, bottom left, I'm pinging that machine, and right is the client, which is actually subscribed to the server. And if this all works, when I pull the power on the server, after about 30-ish seconds, the client should automatically shut down. So we should see disconnect, a power message, and then it shut down and the ping stopped responding. And I have no way to do this other than to run downstairs and unplug it. So I'll be right back. Okay, so don't mind any of my messy cords right now. You guys are kind of getting a little sneak peek. I won't show too much. I'm in new server rooms, and that's coming soon, so make sure you're subscribed. But I'm going to unplug this APC. Now I'm not in there to see if it's actually sending out the message. So we're just gonna wait. And so this is the Raspberry Pi. And so we've disconnected this one right here. You hear it beeping. So after some period of time, this device right here should shut down because it reached a critical level. Yes, there it goes, no more power. Woo, that took so long to configure, sorry. So no more power on this device. So now this Proxmox server, which is my third node, that's another story for another day, shut down. And so now I can plug this back in. And safely power it back on. Yes, I didn't think that was going to work, but let's look at this really quick. Sorry, just reviewing the log. So you can see on the top left, the server said, hey, I've lost line power. Then we see on the client on the right, let me scroll up. Let's see. First it received it's on battery. Then it received automatic power fail shutdown. Then auto log and shutdown proceeding. And then it's going for a power off. And then it powered off now, and then it disconnected. Awesome. And then here we saw the ping stop. So you can see how powerful NUT server is. And this is just one configuration. This is how I have my environment configured. But you could connect a Raspberry Pi or a server or any machine to a UPS and then take action based on those events that happen for that UPS. So no power, low power, running on battery too long, bad communication, the battery's bad, all possible, and all automated. And so I encourage you to spin up NUT server yourself and configure it. I also would love it if you would tell me in the comments below how you configure NUT server. Was mine the bizarre configuration? Or is there something else that you're using? Please let me know in the comments. And remember, if you found anything in this video helpful, don't forget to like and subscribe. Thanks for watching. I keep coming back to Ubuntu. I go on these distro hopping binges every now and then where I'm like, hop on one distro, hop on another, hop on a different flavor of this distro, 5 versions of Ubuntu, Kubuntu, Xubuntu, Edubuntu, to check out all the different UIs. And then I'm like, oh yeah, I'm gonna totally jump onto Mint. And then, those are all Ubuntu distributions, and then I try other Linux distributions, and I always come back to Ubuntu because it's I don't know, dare I say it's the Windows of Linux, but it's pretty user friendly, and things are generally well supported there. And they are other places, but with more tweaking.